Hi guys, and welcome to Calculator Bootcamp Day 4. Today we're going to be looking at how to do confidence intervals on both the 84 and the Inspire. Just a reminder, if you don't already have a calculator, your best option is to go to the App Store on the iPad and download the TI-nspire CAS app, which is currently free. So if you don't have either the 84 or the Inspire already, which hopefully you do, you can download this app, which I think is free until the end of at least to get until the end of April. And that should get you through all of these exercises. I am going to demo how to do all the exercises for today on both the 84 and the Inspire, so you can hopefully watch through and then solve the exercises yourself. Thanks and enjoy. Okay guys, so we're going to look now at the 4 problems from the confidence intervals worksheet. So today, I want to mention again that we're focused on using the calculator to calculate the confidence interval. We're going to assume in each of these cases that the conditions for the confidence interval are met. And now, again, like we did last time, we are really going for core skills. So I'm going to teach you how to use the calculator to quickly find a confidence interval. This is not always the best way you want to go. You want to make sure that you're checking the conditions. You want to make sure that you're writing down the name of the confidence interval. But this is just how to use the calculator to actually find the interval itself. So let's look at the first question. We have a sample of US men with an average height of 5'9" and a standard deviation of 6 inches. And what we're doing is constructing a 95% confidence interval for the true mean height of US men. So we're going to look at this first on the TI-84 and then on the TI-nspire. I do have them in the same window, which should help a little here. So for the TI-84, we're going to go to Stat. We're going to go over to Tests. Now here we have a 1 sample t interval because we were given 1 sample and we're looking at a means thing. So we're going down and we're going to find, hope I didn't miss it. Oh, sorry, they just call it a t interval. Okay, so we're going to go with the stats here. And now we need to be thinking about this a little bit. So our x bar here is 5'9". That's going to be, let's see, 69 inches, and our standard deviation is 6 inches. Our sample size here was 35 US men, and the confidence interval we're going for is 95%, which you can actually enter directly right there. If we calculate, that gives us our t interval. So we've got from 66.9 inches to 71.0 inches, and there you have it. Let's move over to the Inspire and repeat that process. We're again going to go to Menu, Statistics, not Distributions, Stat Calculate, Confidence Intervals. And we are going to a t interval here, nice and simple. And we're not going to use data, we're going to use stats here. Remember that if you had data, you could put in the data directly and have it do the same thing. Our x bar here again was that 5'9", which is 69 inches. Our standard deviation is 6 inches, and our n is 35. We are going for a 95% confidence interval, so we're putting that in, and it gives us our t interval here. So our lower bound is 66.9, upper bound is 71.1. So that puts us anywhere between 5'6" and 71 inches, 5'11". Okay, so this tells us that we are 95% confident that the true mean height of US men is captured within the interval from 5'6" to 5'11". In both cases, that gives us the same interval, which is a good check, being able to use the 84 than the Inspire. Okay, we're going to turn our attention back to the 84 and we're going to look at question number 2. Now in this one, in a sample of 40 US representatives, only 10 do not support the bailout bill for the coronavirus that's giving money to US citizens and money to businesses and some other stuff. So what we're going to do here is in a sample of 40, we had 10 that do not support this bill. And we're trying to construct a 98% confidence interval for the true proportion of US representatives who do support Trump bucks. Let's assume that our conditions are met here. I think the 10% one is just barely met. We also have 10 successes and, 10 failures and 30 successes. And we can assume that this sample is probably random. So let's get into this on the 84. So what we're going to do is, again, go to Stat. We're going over to Tests. And in this case, we have a 1 proportion Z interval, which we're going to find down here at A. Okay, so we bring that up. Now we actually, in this case, have 30 successes, so that's X. We have 40 total in the sample, and our confidence level was not 95, but 98%. From there, we're going to hit Calculate, and that actually gives us our Z interval. So anywhere from between 59% and 90% of the representatives seem to support Trump bucks. Well, let's check this out on the TI-nspire, just to double check. And again, we're going to go to Menu, we're going to go to Statistics, Confidence Intervals, and a 1 prop Z interval. Again, we have 30 successes, we have 40 total in the sample, and our confidence level is 98. And that gives us roughly the same answer. We have 59% to 91% that we assume somewhere in this interval the true proportion is captured. Okay, so somewhere between 59%, we are 98% confident, I should say, that somewhere between the true proportion of representatives who support this bill is somewhere between 59% and about 91%. Okay, let's look at question number 3, this time on the 84. So what we have is a sample of 1,000 residents of New York, where 12 are testing positive for COVID-19. We have a separate sample of 10,000 residents of Maryland, where 12 tested positive for COVID-19. So what we're doing here is we're constructing a 95% confidence interval for the true difference between New York and Maryland in the proportion of residents who test positive, okay? So in this case, we're going to need to go to Stat, back over to Tests, and in this case we have a 2 proportion Z test. We're looking for intervals here, so a 2 proportion Z interval, okay, because we're looking for the difference between these 2 proportions. Let's go with New York minus Maryland here. So we have 12 successes out of 1,000 in New York. We have 12 successes out of 10,000 in Maryland, and our confidence level is going to be 95% that was given in the problem. So let's calculate this. Okay, and this gives us an interval from 0.00402 to 0.01758. We're going to interpret that in just a minute. I'm going to repeat this process on the nspire so you guys can see that. So we're going to go to Menu, Stats, Confidence Intervals. We're going to let's see, we got a 2 proportion Z interval here. We're going to 12 successes, 1,000 trials, that's New York. We have 12 successes out of 10,000 trials in Maryland, and we are using a 95% confidence level. So we'll run that through, and lo and behold, we get the same lower bound and the same upper bound. So for my interpretation here, I would say that we are 95% confident that the true difference in the proportions of residents in New York and Maryland who test positive is captured within the interval from, let's see, that would be about 0.4% to 1.7%, which suggests that New York has a rate of positive tests that's about 0.4 to 1.7% higher than that of Maryland, and that should be percentage points. Let's look at number 4. So here we have a sample of 1,000 residents in the US, and they have an average of 1.9 arms with a standard deviation of 0.1. A sample of 1,000 residents of Italy, on the other hand, had an average of 1.56 arms with a standard deviation of 0.2. Just go with it. I was running out of ideas. So we're going to go to Stat here, and we're going over to Tests. In this case, we don't have a 2 proportion Z interval. We have a 2 sample T test, T interval. So there's our 2 sample T interval, and we're going to use that. So we are going to use the stats here. And in the US, we have an average of 1.9 with a standard deviation of 0.1. and that was a sample of 1,000. In Italy, we have a average of 1.56 with a standard deviation of 0.2, and again that sample was 1,000. Our confidence level should be 98%, and we're actually going to, I think, not pool here. And then we are going to calculate. Okay, so our confidence interval is up there. That's 0.32 to 0.35 with the degrees of freedom shockingly high, 1,469.1. And let's just repeat the process on the Inspire, and then we'll interpret this result. Statistics, confidence intervals, we have a 2-sample t interval here. We're going to go with stats. Remember, you could put in data, but in this case, we're going to go with the summary statistics. So x bar 1, this is going to be the number of this is the mean in the US, so that's 1.9. Standard deviation is 0.1, and our sample size was 1,000. In Italy, we had 1.56, 0.2, 1,000. So it's really just entering those summary statistics as they're given, and our confidence level here was 0.98. Again, we are not going to pool here, and then we hit OK. So we actually get, hold on, did I run that? I might have just closed out of that. Let me run that again. Statistics, confidence intervals, 2-sample t, going off stats. It's fine. 1.9, 1.1, 1,000, 1.56, 0.2, 1,000. Confidence interval was 0.98. Not pooled. Okay. And there we go. So our t-interval gives us, and remember we're estimating here the true mean difference between the, let's see, the number of arms in the US versus Italy. And our lower bound is 0.32 and our upper bound is 0.36 or so. So I'm going to say that we are 98% confident that the true mean difference in the number of arms between US residents and Italian residents falls between, or is probably captured in the interval from 0.32 to 0.35, with, it looks like, US residents having more arms than Italians. So gentlemen, thanks for watching this video. Hopefully by now you know how to do all kinds of confidence intervals on both the 84 and the Inspire. And remember, you're going to need to do more than that with the writing on the test, because you will have to do things like check the conditions and write out what P1 and P2 are, or what mu1 and mu2 are. But this should give you a really tight way to do the actual confidence interval on the calculator very quickly.